Good morning. Now the subject topic is about micro and optical engineering. In this, the microactive device, we are going to see about Gunn diode. Okay. Definition of a Gunn diode is a semiconductor device formed by N-type material. It is also termed as transferred electron devices. As in N-type material, electron act as majority carrier and is a transfer from one value to another. It is a two-terminal device basically made up of semiconductor material like gallium arsenide, indium phosphate, etc. As the material exhibit the property of producing microwave oscillation, Gunn effect is the basis of working of Gunn diode. It is discovered by physicist J.B. Gunn in 1963. A Gunn diode does not contain an p-n junction yet. It is termed as diode due to the two terminal of extremely applied DC voltage. It possesses negative resistance characteristics due to which these are widely used in high frequency applications. Gun diode have the ability to generate continuous power in the range of several milliwatt and frequency nearly 1 to 200 gigahertz, holding frequency about 5 to 15 percentage. 15 percentage, okay. 5 to 15 percentage. The figure below shows the symbolic representation of Gunn diode. See how the anode and cathode represented symbol of Gunn diode. What is Gunn effect? In semiconductor material like gallium arsenide, the electrons are present in high, massive, low free velocity state and high mass, low velocity state and low mass but a high velocity state. By the application of sufficient electric field, this low mass, high velocity state electrons are forced towards the high mass state. At this particular state, the electron from a cluster and thus move at a uniform rate, thus causing a flow of current in the form of series of pulses. This is termed as Gunn effect, and it is utilized by Gunn diode, hence named so its Gunn. Construction of Gunn diode. See how the Gunn diode has represented here by the diagrammatic representation, picture representation. Anode and cathode has been a top layer and a bottom layer. Gold thin film in the first layer. Next about N substrate, that is gallium arsenide, and next in active layer and N substrate of gallium arsenide. 15 micrometer and 5 micrometer and 15 micrometer are presented. The structure of Gunn diode. We already discussed that a Gunn diode is not a p-n junction diode as it is composed of only n-type semiconductor material. The figure below represents the construction of structure of Gunn diode. Here a lightly doped n-type semiconductor layer is present between two heavily doped n-type material. The middle portion is termed as active layer. The thickness of this region is around a few micron to several hundred micron. The arrangement of Gunn diode is formed by growing an epitaxial n-type layer over an n plus substrate. The two highly doped regions provide better conductivity to the device. The whole structure is mounted on a conducting base that acts as a heat sink for the heat produced during operation. Also, the other terminal is formed by connecting a gold film over the top surface of the structure. Working of Gunn diode. The operation of Gunn diode depends on the Gunn effect, which we have already discussed in the previous section of this article. That is, so we let me know about how a Gunn diode operate actually. Working of Gunn diode. When a voltage is applied to this device, then this external potential appear across the active layer, thereby causing the flow of electron present in that region. This flow of majority carrier causes the current to flow across the active region of the device. Once the current pulse starts traveling inside the active region, the potential in that region falls, due to which no further formation of current pulse occur. But once the previously created current pulse reaches the other end of the active region, then the potential again rises, leading to the generation of another current pulse. Thus, the frequency of operation of the device depends on the time taken by the pulse to travel to another end. Resultants will be on the rate of pulse generation. Unlike a normal junction diode, a Gunn diode consists of three energy bands namely valence band, conduction band, and extra band above the conduction band. See how it is represented here. Okay, this thing will be explained by the Gunn transferred electron effects. So from this we are saying about the points, how the Gunn diode peak input, peak point, operating voltage, conventional diode current, maximum operating point, valley point, negative resistance, and tunneling current, VI characteristics of Gunn diode. In this, we have to see the main purpose of this will be negative resistance region, where the peak point to valley point will be the negative resistance region. This is the main purpose of Gunn diode, where we are utilizing in many cases of applications. See, the manufacturing cost of Gunn diode is low. Gunn diode are highly reliable, and it is comparably low operating voltage in the normal diode. Its installation circuit is easy. So Gunn diode find their application in oscillator, amplifier, in ultrasonic detectors. There are also tachometers and radio communication systems. Whereas in disadvantages, they are less stable. Okay, any queries?